Alright, hello Algebra 2s. Here's a little warm-up for you. I hope you put some brain thought into it before you opened up the video to watch the solutions. We'll see how you did. Alright, putting it all together, I wanted to give you a one of each type of quiz. And our focus here is really taking a look at what sign is in between the fractions so I get a better idea of what math I can do with them. Okay, so what operation do you see between the fractions? This is multiplication. So do you need a common denominator? No. Do I need to multiply the inverse? No. My next step is to look to see if any values in the numerator on each denominator of the fraction can be factored. So what I'm going to do is deal with each of my parts separately. So I'm going to look here and see if I can take that quadratic trinomial and split it into its two binomial factors. X squared factors into x times x. My 48 is going to have factors with the same sign, and that sign is going to be negative. So two numbers that multiply together to give me 48 and add together to give me 14 are going to be 6 and 8. Now here's a little secret. When you factor these problems, chances are you're going to get a factor or two that is familiar. So if you're struggling here with these factors, take a peek and see if there's not something that might be able to cancel out further on in the problem. All right, so I have x minus 6 times x minus 8 all over x times x minus 6. Now multiplying fractions is no problem. Top times top, bottom times bottom. I can list each of these factors in that numerator or denominator. My next step is anything that is an identical factor in the numerator and denominator can be canceled out. So this is the fun part. We want to make sure that we protect those bubbles, knowing that this bubble x minus 8 and this bubble x minus 8 are identical. We know that this bubble x minus 6 and this bubble x minus 6 are identical. When I go ahead and I cancel my identical factors from my numerator and denominator, my only thing left to do is simplify my expression. In my numerator, I only have a 1, and in my denominator, I have an x and I have a 3, so convention says to write that as 3x. Make sure that these values stay in your denominator. That's a big mistake that I'm seeing some kids make. All right, next up, number 2. What operation sign do we see between the two fractions? Guess what? Division. So when I look at dealing with a division problem, do I need a common denominator? Here's my division. No, I do not need a common name. Do I need to multiply by the inverse? Yes. Multiplying by the inverse is going to allow me to divide these fractions. Now I'm going to see if any of the values in the numerator and denominator of each fraction can be factored. Here's the biggest thing that is the most missed in this type of problem is make sure you put this over 1. Make sure you understand that that's the clear numerator and denominator. I'm going to go ahead and factor because this can be 2x minus 3 and 2x plus 3. This is the difference of two perfect squares. The square root of 4x squared is 2x. The square root of 9 is 3. This plus and this minus sign are guaranteed that the middle term cancels out, which is why I end up with the difference of two perfect squares. All right. So I have 2x minus 3. I'm going to bubble wrap that and place it over 1. I'm going to multiply by the reciprocal. X plus 5 goes in the numerator. 2x minus 3 times 2x plus 3 is in my denominator. Keep in mind, these inverses undo each other, which is why these values need to be flipped. My first fraction stays the same. Alright, so, and of course that makes it nice because of now I have a value that can be canceled out, 2x plus 3, which my final answer then is x plus 5 over 2x plus 3. And that is my final answer. Keep in mind, these parentheses at this point are unnecessary. If I wanted to write that as x plus 5 over 2x plus 3, these two values are the same. So those parentheses are more for clarity at this point than anything else. All right, let's take a look at number 3. When I look here for number 3, I'm going to take a look at what operation I have, and this is an addition problem. All right, so we have a whole new conversation here. What operation sign do you see between the two fractions? I see addition. Do you need a common denominator? Yes, you do. And you're going to have to look at what factors are a part of that least common denominator. If I bubble wrap this factor from fraction 1, I need an x plus 3. From fraction 2, I need an x. Therefore, my least common denominator is going to be x times x plus 3. This is a 3. So when I go ahead and I want to think about giving each fraction what they need. So when I go to write my new problem, each of these numerators is going to be an x plus 3 times an x times an x plus 3. So what do I need to make that happen here? I need an x over an x. Hey everybody, this is a form of 1. It's not going to change the value of my fraction, but it will make my denominator match. So 9x is in my denominator. Now, of course, you could cancel these out to go back to a simplified version, but that's not what I want. I want to have this common denominator. All right, so here, when I bubble wrap that, what I need to make this match is an x plus 3 over an x plus 3. This fraction has a form of a value of 1. I'm not going to change the value of this fraction, but what I will do is I will give myself a numerator and a denominator now that matches. So when I go ahead and I add these fractions together, I have 9x plus, now I need to multiply these together, x squared plus 3x minus x minus 3. And remember, that's all over my common denominator, x times x plus 3. So I'm going to come over here and continue my work, put it in standard form. And when I put it in standard form, my x squared comes first. I'm going to combine all of my x's. 9 plus 3 is 12, minus 1 is 11, minus 3, and I have here over x times x plus 3. Now here's this next point where I want to make sure that I look at my fraction carefully and make sure I can't factor this, and I make sure that I've got nothing to cancel out and it looks like I'm good. So we'll consider this as my final answer. Okay, let's take a look at the back. Now I have my next conversation, which is going to be a subtraction sign. So what sign do I see? I see a subtraction sign, which means I'm going to add the opposite and I'm going to bubble wrap. We want to make sure that that negative is applied to each of those terms in that denominator. That's very, very, very important. Okay, so now I'm going to go ahead and think about these questions. Do I need a common denominator? Yes, because I'm adding. Before I can list my factors, I have to go ahead and factor each of these denominators. I can take a 5 out, and I have an x minus 2. I can take a 5 and an x out, and I have an x minus 2. So when I talk about what factors I need, from my first fraction, I need a 5 and an x minus 2. From my second fraction, I need a 5 and an x minus 2. So my least common denominator is going to have a 5, an x, and an x minus 2, because that's going to consider each of these factors that's necessary. So once I break these down into factors, now it's time to go ahead and rewrite them using a common denominator. That common denominator is going to look like this. I need a 5 and an x and an x minus 2. So when I look at these two fractions, what is this fraction missing? It's missing the x. So I'll go ahead and I'll multiply this fraction by x over x. That's going to give me x squared, and this x times my 5 times my x minus 2 is right here. Now I have my plus sign, and I have my opposite of x plus 2 in my numerator. When I look at my 5 and my x plus 2, this denominator has each of the required factors. So now I can continue simplifying by adding the numerators only and including each of the factors on my common denominator. X squared minus x minus 2 is in my numerator. When I go ahead and I consider standard form, I already have my x squared up top, but guess what? I have to check and see if this fraction can be factored. My denominator, 5x and x minus 2, stands. When I look at factoring this, I'm going to go ahead and put an x. Negative 2 comes from negative times a positive. I have more negatives than positives. So is negative 2 times 1 equal to negative 2? Yes. Is negative 2x plus positive 1x negative x? Yes. That means that these two factors can cancel out. And my final answer is x plus 1 times or over 5 times x. So we have this first step where I looked at the factors of my denominators. I have this second step where I created common denominators. This third step where I added my fractions. This fourth step where I factored that numerator. And finally this fifth step where I went ahead and I simplified that fraction. Alright, so when we look at our next problem, number 5, this is what we call a complex fraction. And with a complex fraction, we want to make sure we have a clear numerator and denominator. And this value that's down here in the big fraction is what's keeping us from doing our next steps. So we have to fix that. Here's our big fraction bar. And we're going to go ahead and do some math down here. So my numerator stays the same. And I'm going to go to work on my denominator. I need a common denominator of x plus 3. So I'll go ahead and multiply by x plus 3 over x plus 3. That's going to give me 2 times x plus 3 over x plus 3. and that's going to be added to 1 over x plus 3. Now that I have a common denominator, I can go ahead and combine those like terms. Here was step 1, here was step 2, step 3. Notice my numerator stays the same. I'm just waiting for when I can rewrite my fraction horizontally. I can't do that until this is a clear numerator denominator. Okay, here's my big fraction bar, and I have 2x plus 6 plus 1 all over x plus 3. And we can go ahead and know that that's going to combine to equal 7. Alright, so we'll come up here to step 4, where I can rewrite my fraction horizontally. So 5 over x plus 3 can be divided by 2x plus 7 over x plus 3. When I divide fractions, I'm going to multiply by the reciprocal. Of course, these values now, one is in the denominator, and this one, when I went for my inverse of division and I flipped my fractions, that reciprocal now has that x plus 3 in the numerator, and they are values that can be canceled out. My final answer, 5 over 2x plus 7. Keep in mind, this fraction bar divides our numerator and denominator, becomes our division of our top and bottom fraction, and then of course that's what becomes multiplication when we flip these two fractions. Alright, last problem. And I want you to think carefully about what's happening here. We asked you to look at all kinds of signs, and we reviewed when we were adding or dividing. Notice the difference between these words. When I'm simplifying, I'm just coming up with a simpler expression. When I'm solving, I'm actually going to be finding a value of x, and this equal sign makes all the difference. So when you look at these problems on the front page, there was no solving. All I was doing was evaluating, simplifying, combining like terms. Notice there was no denominator crossing off because I didn't have it equal to anything. This last section of this unit has us solving. And when we are solving, the primary thing that we need to do is find the least common denominator. And guess what? When we find that least common denominator, that's when I can cross it out and address my numerators only. So this is a great problem. It's got everything all rolled into one. My first step is factoring. I'm going to split my x squareds into x and x. 8 becomes plus 4 and plus 2. When I look at these common denominators, when I want to find them, my first fraction has an x plus 4 and an x plus 2. My second fraction has an x plus 2, and my third fraction has an x plus 2. So guess what? My least common denominator is going to have an x plus 4 and an x plus 2. So this value is fine. I can rewrite him as is. His denominator is my least common denominator. Now let's talk about this fraction. He has an x plus 2. He needs an x plus 4. So I'll go ahead and multiply the top and the bottom by x plus 4. That's going to give me x plus 1 over x times x plus 4 over x plus 2 times x plus 4. Here's my form of 1 right here. So that's going to be equal, this last fraction also needs an x plus 4, on the top and the bottom because all I have is a 1. X plus 4 is in my numerator, and my denominator is going to be this x plus 2 times this x plus 4. Here's the cool thing. When I am solving equations, I'm looking for the value of x. That means that this 3 plus this expression equals this expression. So guess what? My denominator, now that it matches, does not need to be a part of my problem anymore. That's that crazy fact. So I have 3 plus x plus 1 times x plus 4 is going to be equal to x plus 4. If I can make these two sides of this equation equal, then this is true too. That's why I'm able to cross off my numerators. So we need to FOIL this. 3 plus x squared plus 4x plus x plus 4 is equal to x plus 4. We'll go ahead and put this in standard form. Here's my x squared. This looks like 5x plus 7 is equal to x plus 4. This is a quadratic. When I solve quadratics, I need to set them equal to 0. So I have x squared plus 4x, because I took 1 away from each side, plus 3, because I took 1 away from each side. Now this is a quadratic that I have to solve. You absolutely have to solve the quadratic. You can't skip it because it can't be factored. You know how to solve. And when we solve a quadratic, you have a bunch of different strategies. Number 1, are you going to factor to solve? If not, you have your quadratic formula that always also works. So we're lucky. This one can be factored. So I have my x's split. Two numbers that multiply together to give me 3 and add together to give me 4. X has a value of -3 and -1. But wait. Before I count either of these as a solution, I have to go back into my denominators and I have to see if -3 or -1 is going to give me 0 in any of these values. It looks like I'm lucky. So a -4 and -2 would be what would give me 0. So these are good answers. So I wanted to make sure that I checked my work and that those answers are good. All right, here's today's task list. So the first thing that you're going to do is complete this warm-up and check the warm-up with a video key. You're going to check your homework. It's not the review sheet, it's the homework 6-8. And you're going to complete the reflection. So this reflection is for the warm-up and the homework. I want you to make some notes about things you need to remember. You're going to turn this paper in to the teacher and they're going to give you a quiz. If you sit on the door side of your table group, you get A. Window side gets B. You're going to complete your quiz independently, turn it into the inbox for grading, and then your Unit 6 review packet you can pick up from the teacher. All right, keep working hard. We'll see you soon.